Hi, I'm Thaddeus McNamara, and until recently I was an overworked but well-off and accomplished master prosthetics craftsman. I'd work day and night, 8 days a week, making bespoke and unique body parts to substitute those that others had lost. I worked my fingers to the bone and then beyond, and then made myself new fingers with my nubs. Then, one day back in 2011, some cosplay geek named Ivan Owen printed a kid named Liam an affordable custom prosthetic hand and could revise it and reprint it as Liam grew up without huge costs and waiting times and insurance. My days of being a well-paid Geppetto, making people feet just so that someone could stand up and say, "I'm a real boy," were definitely coming to an end. But as this new technology disrupted my life, my livelihood, and my income, I didn't cry because the glue fumes had fused my tear ducts shut years ago. No. I got on that trolley, I embraced the new, I learned the skills and adapted with the times, and today I'm making some money? Alright, now that my credentials are well established, let's set some boundaries for this video. The focus is about modern additive 3D printing and fast fabrication. I will speak to the history of making stuff, but we're not going to be talking about those guys who can turn a log into a canoe in 4 minutes, although they are very fast. And we're not going to be talking about the process of making little humans, which is technically an additive layering process, but it takes 9 fucking months. We're talking about fabrication now. For a while now, humans have been a bit arsed about tit when it comes to making things, compared to how we might moving forwards. We took a block of something, it be a sediment buildup, or a tree that built layers and rings over years, or just a huge slab that was created by flowing a whole bunch of lava down a hill. And then we'd just chip away at it, or we'd stab it, we'd cut it, or just rub it. Until we got something out of that. And we did this for about 5,000 years. Let's go through the subtractive manufacturing processes in a rapid fire manner. About 3000 BC, the Egyptians first started logs turning and tooling, which allowed them to make some very round logs, probably helped the aliens roll some blocks down a hill so they could make the pyramids. Then you had at about 1000 BC, the Chinese had already worked out milling to the point where we could mill metal, we could mill wood, we could mill gems, probably. Milling gems, probably a thing. But, more to the point, we could mill things like rice, which led to brown rice no longer being the predominant rice. We now had white rice. And that changed the world, but also, who cares? We're not talking about it. We had 1751 as the most next interesting one. Some French dude named Jacques de Vaucanson, I think it was, made an industrial lathe for the first time. Now, little did he know that would be made for making 22 caliber pen shooters in the future, but like many French things that ultimately led to killing people, he was ahead of the curve. We like the French for this, or do we? Then we jump ahead to 1775, where we have John Wilkinson creating a precision boring machine, which hugely improved the performance and efficiency of the steam engine. Now, the steam engine is important in our overall growth as humans, because trains, and I like trains. But not only trains, it was really responsible for making the second industrial revolution more viable than it could have been otherwise. But trains. 1818. Eli Whitney. He was an American man who decided that he was going to standardize the milling machine. He did so using American units, freedom units. Now, I don't know how many tenths of what number of inches a millimeter is, but I know that 16/18 of a 19th of a 22nd of my furlong's left nut is a relatively poor unit to be used. Jump to 1952, the first computer numerically controlled device, a CNC, a milling device that allows you to automate some degree of reductive fabrication. I just want to call this one out because I could go and buy a 5-axis CNC today, yet where's my tesseract? How many axes do you need? You've got up and down, you got left and right, you got forwards and backwards, you got through fucking time and through fucking dimensions. What is the 6 axis? Like, at what point in time are you going to be able to reliably let me give you a chunk of aluminium and give me back a fucking tesseract? Come on, pick up your fucking game. And let's be honest, everything that we did up until this point in time was literally one craftsman, one reductive process. Nobody was building things in an additive way. Even Michelangelo's David, one individual operating a chisel in a removal reductive way. Block of materials you were removing things from predominantly, almost exclusively, and you needed the craftsman to know the art of what they were doing. That all changed. I mean, I'd like to say that all changed, but I'm still a firm believer that the vast majority of people out there have no idea what they're doing, and if they had even the slightest inclination towards understanding what they were doing, I'd invest in rope. We here at Wacknamara Industries may invest in rope, but our goal as an organisation is to help share, learn, explore concepts and ideas that might not be familiar and uplift the entire human race. I personally know fuck all about anything, and that's why we're invested in rope. At this point in time, we skip forward to the new epoch. I like to consider Hideo Kodama in 1981 as the original additive printing fabrication godfather. He had the idea that you could lay down some goo and harden it with light and then additively build up layers. Didn't get the patent or the funding. The next guy along the line in 1984 was Chuck Hull. Chuck Hull was a guy who made furniture. Kind of like IKEA, but not as good. And Chuck Hull? Wait, do I have one of those in my drill? A Chuck Hull? He came across the idea and patented the idea of additive 3D resin style printing. SLA. We'll get into the definitions later. In 1989, Scott Crump came up with FDM printing. Instead of shooting light at layers of resin and building it up that way, it was much more like how frogs breed, laying down spawn over the top of itself over and over again while extending the legs of the frog up and just spunking more. Look, it's frog spunk. FDM is spraying frog spunk in layers. I love my pond. Modelling. The next most notable one was a company named Organovo back in 99. They claimed they were going to be printing 3D organs. Since we don't have 3D printed organs, we can make some assumptions about their progress. There was a 3D printed kidney, but it didn't work. But it did have some kidney cells in it. It was shaped like a kidney. So it's kind of like sending a kid a tin full of sherbet saying it's a jelly bean, and when they open it up, it's not. And they're upset. And their parents are upset because the sherbet spilled on the carpet. And the kid doesn't have sherbet now. And nobody gets anything out of this experience. About the same point in time, there were some of these industrial protein printing or fabrication startups happening as well. What would have been very cool is if Garnovo, they had have gone out and looked for venture capital in the fast food space. Let's be honest here. I'm putting my hand up right now. I would absolutely go and hit up a McLung or a McLiver. I need a McLiver. Who else wouldn't go out and go get a McBrain, a McLung, like a McArse? Like, as it is, we're already eating seafood sticks made from God knows what pig arseholes. Why not celebrity arseholes? Like, they were this close. They could have gotten funding. But then it was 1999. At that point in time, even little old me was sitting there not realizing exactly how funny cloning celebrity arseholes in order to make the best seafood stick in the world could possibly be. Now we hit another one of those epoch points. 2005, RepRat was the first modern 3D printer, which is in line with what we know as 3D printing for the home or the industry today. Adrian Bauer, who was a significant proponent in all of this, an engineer, did so because of the fact that he wanted to see self-replicating machines. Adrian, I might have my issues with all of this from time to time, but surely you've watched some Stargate, and surely you've watched any other dystopian self-replicating sci-fi. Because if I remember correctly, your reason for getting behind this whole project is to make self-replicating robots. Why? Did you not read the part where the paperclip gets maximized? Do you... actually, no, you probably have a point. Von Neumann probes are pretty cool. Yeah, they've got the Scandinavian name Von Neumann, but they also have the word probe. And as all good things come to an end, a patent did. Now, patents coming to an end is basically my favorite thing in the whole wide fucking world. Because in 2009, the FDM, the one where we frog spunk, we melt things and we squeeze them out of a frog spunk, patent came to an end. And suddenly the entire world could squeeze one out and make whatever they like. Instead of becoming a industrial rapid fabrication tool, people just got to fabricate stuff. We got to make stuff at home where their stuff was. I tend to use the dental industry as a little bit of a litmus test with technology because of the nature of teeth. We all have very individual teeth and, well, at least some of us are missing them. Collingwood supporter. Look at dental technology growing new teeth for stem cells or how they do dental prosthetics as a little bit of a litmus test for where the industry's up to. It was roughly between 2012 and 2015, 3D printing, resin printing, using some pretty specialized materials, became popular and in fact overtook the old cast and mold approach to dental prosthetics. We're 10 years out of what I would consider the tipping point of rapid manufacturing. It's not something we're talking about coming tomorrow. It's here now. And that's actually the trap I've got you in. Trap? What trap? Who mentioned a trap? I didn't. Let's think back to the guy Ivan Owen who potentially ruined my earlier career. He was part of Enable. They've done something to the effect of 10,000 deliveries on prosthetics. And they removed so much of the cost. We're talking a reduction from like $50,000 down to $50. That's a factor of about 1,000, and I'm not good at maths, but that makes sense. This really does change the world. And let's not even start with the fact that some of the stuff that these guys are making is better than what is commercially available. Oscar Pistorius was a South African runner known as the Blade Runner, and he managed to do a 10.91 100-meter sprint using commercial carbon fiber prosthetics. We know today that unique custom prosthetics that can be 3D printed using stuff pretty much home available are better than that. If you're a kid out there who has had a traumatic injury, lost some toes, a foot, a leg, both legs, remember that just like Uncle Oscar, you just need to shoot your shot. Fused deposition modeling or fused deposit manufacturing is take something, melt it, and then squeeze it, layering it up, like as I said before, frog spunk on a pond. The general materials used, it's about oven temperature. A nozzle around about 0.4 is usually the biggest ones, but then you get down to 0.2 these days. It takes something, melts it, squeezes it through a syringe-like apparatus or an aperture, paints itself like hot glue, and you get products like this. There's a whole bunch of different materials you can print with. Most of them are plastics, and at home, most of them are pretty benign. The biggest issue you're going to have is that if it doesn't stick to your build plate, or if it doesn't stick to its previous layer, you're going to get giant pubes of very fine plastic in a heated environment that could latch around something and create fire. This technology can pretty much extrude anything that can be tolerated, melted, and then printed using 3 dimensions that exists. Could be my balls, could be a house. It's literally what got 3D printing into schools, into homes. It led the charge, even though it wasn't the first one that was actually developed or even particularly a good one. SLA, or stereolithography, I still think that the A is missing. Stereolithography what? Stereolithography... What are they saying without saying the A? You know what I mean? The SLA resin style, apply light to harden layers approach to printing, took a little bit longer to get to the home space, but it was actually my first 3D printer. This is the same set of balls you saw before, but printed using stereolithography, SLA balls. It is more detailed. You have a resolution that allows you to cure shapes based on the screen's ability to expose UV to the layers of resin. Hold that thought. See, hold that thought. What we have here is a jar of crystals. What SLA does is essentially shine a light and create crystals from the bottom up instead of from the top down by going and shining light on the bottom of the thing through a semi-transparent, essentially a phone screen that is designed to cure UV light. And just like my failed fucking crystals here, if something goes wrong at the very, very start, the whole thing is cactus. Top that off with the fact that, kind of not unlike, but vaguely unlike my shitty crystals here, the resin is exceedingly toxic, lives in liquid form. It's horrendous. I don't actually think we should necessarily be handling this stuff at home because of one particular reason above all else. If I said in a different video that copper sulfate solution is the worst tasting thing in the world, I can tell you right now, the resin that helped me make these nuts is the second worst. The final major technique, and one that I will not be speaking about particularly from here on out, is SLS, which is something to do with laser scintigraphy. Basically what they do is they take the same vat of resin or liquid, or they take a bunch of dust and they shoot it with lasers and they build it that way. Honestly, it is completely unfeasible for home use or hobbyist use. It's very unlikely that we'll ever see it in any sort of amateur, less than industrial environment. It needs to be called out because imagine this, you've got a cube of a liquid. If you shoot a laser into it down a line, that line will build great, now you've got a stick. I know a stick is great, you break it in half, now you've got 2 sticks, you're doubly powerful. fuck off. There are some ideas around the way that you can interact lasers in the same way as they came up with this idea for radiography for cancer treatment. It's a fairly inert beam, wave, form, whatever, shot in one direction, and it penetrates the whole axis. You've managed to go through the whole thing. And then what you can do is pepper that, or alternatively interact, cross-section that, and I don't know how many axes you can do this on because I don't have a fucking tesseract. You can basically go, this laser does nothing, this laser does nothing, but when they interact with each other, then they solidify something. You could have this giant vat of powder or goo that you're shooting lasers through, and you can actually grow something out of it. And I don't know if you noticed in both cases of these that they both have some waste or supports involved. It's actually, supports are the worst thing in the fucking world. If you can do really cross-sectional growths, you don't need to put any of this sort of stuff in there to deal with the overhangs and the underhangs. And if you see the sci-fi things where they like make a fucking cup of tea and a thing, you're not going to use nanites, fucking Iron Man. You're not going to get to that using these things. So, quick comparison of the two major ones that we have available to us. We have ourselves the frog spunk method, and we have ourselves the build it up upside down crystal method. This one, if you can get your butt layer to adhere and you can get every other layer to adhere on top of it, you can pretty much print anything. They're using this sort of stuff in 3D tissue. You print the muscle and then it goes, oh, nope, not muscle anymore, and it changes over to a different nozzle, and then it starts printing blood vessel, and then it changes to a different nozzle, and it starts printing like subcutaneous like fat and collagen. Honestly, they're doing the Age of Ultron made of plastic. What was his name? Human Man. Hawkeye thing. And you can build layers upon layers, and as long as you can get your layers and your fidelity small enough, that's wonderful. This is SLA printing, and it gives actually really good detailed results. I handle a lot of the materials and I'm not sure it's very healthy. You might notice that I've burned my balls because this is cured with UV light, which also gave me eye cancer in a prior video. It does mean that you can have essentially as high a resolution, as high a fidelity as you can make LED pixels. Now, I've also did a video on LEDs, watch it. You can actually have nanopixels. So we're getting to the point where, theoretically speaking, we can activate materials at a sub-molecular? No, there's got to be a molecule in there somewhere. Definitely subcellular level. That's the other side of things. It's not all about printing little toys. I love ripping off a good company here and there, but it's not about that. It's about a revolution in how things are built and distributed. This is a roll of some random plastic. We melt it, we print it. If it doesn't turn to pubes and catch fire, everybody's pretty happy. There's a couple of versions of this that might be a bit more dangerous to handle, but generally speaking, it's not too bad. And the same process can be used for a lot of metals. Really, as long as you can melt the metal and you can extrude the metal in this way, you know, you can rapid fab using essentially the FDM process. And as far as home use goes, does the job. On the other hand, if I want to do some really interesting work, I need this horrendously toxic, how am I shaking it? Photoresponsive resin. It's actually quite cheap. I'm not sure which one works out cheaper when you work out measurement for measurement, waste per waste. But the one thing I will say is that I hate with a passion. Not when something goes wrong with the first layer of the print, but about halfway up, because then I've got to work out what's stuck where. Or this. Look at this. It started, it went up and down and up and down, and now I've got a blob of shit and a whole bunch of crap in the bottom. I'm going to clean this whole thing out, and I still don't have anything usable. Also, you can't print a dildo with this. One last consideration is the impacts on the environment and the person between those two major SLA and FDM printing types. FDM encourages a hell of a lot of waste because you'll do one-off prints, it's very easy to work with, you'll end up with leftover bits of reel that you never finish, as well as all of the knockoff parts. And I'm not saying knockoff parts don't happen with the SLA as well, and that's actually also a consideration. SLA also has the thing where you've got to cure it before you dispose of it, because liquid resin, we're pretty much assured to fill everything with microplastics. I, just before this video, printed off the material safety data sheet for the resin that I showed you just a moment ago, and here it is. Turns out I'm fucked based on the amount of exposure I've had to the SLA resin, even with the best effort of my handling, and the fact that I've suddenly grown giant man titties and essentially glad wrap that comes out these days. I'm pretty sure that these balls and mine don't have that much difference between them. I'm considering installing one of those little serrated cutters at the front. What is it that makes 3D printing so bloody scary and so bloody amazing at the same time? It's changed the world and you haven't even noticed. Foreplay aside, now we're getting to the point of the trap video that I promised you all along. The future is fabricated. But that I hear you say, what is this thing I haven't noticed and how is there a trap? Well, firstly, there is no trap. Nobody mentioned a trap. Secondly, well, it's not just about some people making some little toy soldiers. That is an important part of it. What it is power. Like all things, there is a power balance that's shifting because of technological change. Without getting too anti-anything about anything here, we have been somewhat conditioned into product. Product and thing, we like product. And there has been a degree of control applied over us with regards to what products are available and what products are good and where we have to get these products. 3D printing is an opportunity for that shift to occur. Now, I'm not saying that anyone's out there 3D printing guillotines and about to take over Apple yet. But what I am saying is that there is a very big tie-in with the democratization of manufacturing and a challenge to existing power structures. And I promise you this video still will be funny, even though it's pretty dark. Look, we're going deeper than my plasticized junk could ever do again. Strap in and enjoy the ride. Let's consider this. We're actually in a fourth industrial revolution. The first one was all about steam power. Suddenly, the power of one engine or one man could do the work of a great many. The operator or the engine itself became a team. You have the second industrial revolution, which essentially brought electricity into the play. We had mass production with our good Lord Ford. And he made a lot of cars very cheaply by having people do very samey things over and over again in a line in order to have an output that was greater than the sum of its parts. The third industrial revolution was around computers, it was around automation. So instead of having a production line, which was lots and lots of people doing their little things, which created something greater than the sum of their parts, what we had was machines doing very many little things, and then people finishing, or even if finishing, to create something greater than the sum of its parts. So working backwards from the third industrial revolution, what we have is a bunch of computers and automation being able to replace some people. And then going to the next step prior to that, we had a whole bunch of people being able to create things greater than they were able to in isolation. Then going back to the first one, what we had was something replacing the work of some people. So where are we at with the fourth? Well, it's right fucking now, okay? So now we're finding ourselves in the fourth industrial revolution, and ultimately what that is, cyberpunkish, not as it may have been written in the 80s. What we have is the ability for people in a global connected network to collaborate, then for the outputs of their collaboration to be produced by one or very few people without the industrial production line that preceded it. So if we step back through it from the start, first industrial revolution made lots of people, one person. The second leveraged that using lots of people doing small parts of the piece in order to create something greater than they would have been able to in isolation. Third industrial revolution managed to again reduce the number of people while also leveraging the power from the first, process of the second, in order to be able to create large numbers of things that were greater than their parts using very few people at all. Things started getting very complicated and you still needed the intelligent design behind it. The fourth industrial revolution does two things in particular. The first one is that it allows for the global communications network to reduce the amount of challenges with regards to that thinking, that design, therefore informalizing the inputs to the automated production line. Also, now the gateways to the manufacturing, the automation, the computerization, the challenges with actually being able to create something because the entry gates are so much lower are also somewhat distributed. If you have the ability to fab a few circuit boards, 3D print in 2 or 3 different materials, you can probably create something which is just as good as something that is mass produced. Now, is that going to be cheaper? Perhaps not. Is it going to be more specific to your requirements? And is it going to be able to be done without the control of information properties by large companies? Oh, abso-fucking-lutely. Stay with me. Alright, so let's not worry about the large company control for a second. Let's say that you've got a machine and your machine breaks down. Currently, if your machine breaks down and it's specialized enough, you probably are going to have to order a spare part from overseas. That spare part will have to be shipped to you where you can then possibly, probably, maybe, depending on how specialist it is, install it, or you'll need to have somebody potentially fly in to do the installation of that particular part. What's going to change very, very quickly is that instead of a physical item moving from point A to point B in order for you to get back online, and let's be honest here, some of these machines you're losing millions of dollars an hour when they're offline, what will be transmitted is a file, a design, a schematic, and it might be controlled by some sort of rights management, but you'll be able to get file, use a local or in-house fabrication device to produce thing, and then with either telepresence or a good old fucking Zoom chat, swap that part in. Now suddenly, instead of waiting for a rapid flight, which could still take 12, 18 hours, I don't know, or even sea freight or something even worse, you're now not losing millions of dollars an hour. What you're doing is watching the thing go and as fast as you can get a short lifespan replacement part into that machine is your downtime. Now, it might take longer for a proper part to come over and replace it, but in the meantime, you're not losing millions of dollars a minute. I know this doesn't make a lot of sense to a lot of Australians because we don't have a manufacturing industry anymore, but we are trying to make an advanced fabrication industry, so this could be good. Instead of losing millions of dollars an hour, your machine's still running, and perhaps you need to have a 1 hour downtime every 48 hours for another one of these rapidly fabbed parts to be swapped in and out and in and out and in and out while you wait for that plane to come over or them to mill the real part and ship it from wherever. Right there, what we're seeing is essentially a change between the transfer of physical things to the transfer of digital things. And that's very important. As it is, it's not like everything isn't done in SolidWorks or AutoCAD these days anyway. These models exist now. It's all about materials. To do the differentials, In the first industrial revolution, you still needed some workers. You needed the factory, you needed the steam engine, you needed the water wheel and the mill, but it reduced the amount of people turning the mill from a chain gang to one water wheel or one steam engine. Huge efficiency there. Your foreman essentially became a machine operator at that point in time. Foreman's a strong word, or weak word. In the second industrial revolution, you still needed to have the process assembly line and capital. So you needed to be able to pay the people, you needed to be able to design the process, and there was still machines and fabrication involved in that as well. So it was expensive. You essentially did need capital to nail up the factory. And I still think that a lot of the global venture capital investment is still oddly somehow hung up with some of the concepts of that second industrial revolution. In the third industrial revolution, you could get rid of some of the human capital. You were now replacing it with machines, automated machines, and we have car factories that were doing this very early in the piece as a great example. We could replace a bunch of humans, but what we needed was robots, and what we needed was computers. And again, it was rather expensive, but instead of needing people who could do precision machinery, what we instead needed was programmers. That leads us up to pretty much last year. Not even, a year before, a couple of years now. But where we are right now, the tipping point is past. Fourth industrial revolution. If I want to build something today, I need the right fabrication printers and I need an internet connection. And I may need a handful of semi-cluey engineers to fill the gap. Instead of requiring the full force of, let's say, Toyota's production lines, theoretically speaking, a dozen guys could start printing cars out. Just data, just printers. But what about those engineers? What about just one? We have online services where an engineer who knows enough can magnify his knowledge using AI. And since the second industrial revolution, where we designed modularity, it's really not a stretch of the friendship to say that standardized, readily available, modular parts, a cluey enough engineer, enough printers, and a little bit of ingenuity could not build new things. And you won't even need to put not happy catching nets around a building because you don't have a bunch of workers who are very much not happying themselves to the ground. And this closely overlaps, though there is a bit of a lag when it comes to globalization. Ooh, globalization. Those sneaky people. Now we've talked about the industrial revolutions, let's speak about the different waves of globalism. The first wave of globalism came with steamships and guns. Thank you, Britannia. It was brilliant. And the second wave, it was more about container ships and jets. And manufacturing came where labouring was available. So if in the first wave we moved materials, be it by train, by boat and gun, in the second wave of globalism, what we did was put manufacturing, in theory, closer to where materials were, or at least where labour was. And we built things near the source of the stuff. In the third wave, we got to a degree of digitally driven obsessiveness. So you could have your stuff, which was able to be extracted and moved to where labour was cheap to make your things, but they were only parts of your things, where you could have those coalesced at a different point and constructed into your things in order to have crap arrive just in time for it to be put on shelves and available to the consumer. Those three roughly overlap, though lag behind, the Industrial Revolutions. Weirdly enough. What makes the fourth wave interesting is that it's got two possible directions it can go in. One of them is hyperglobalization, and the other is nationalistic, contracted relocalization. And if I've talked about us going into a fourth industrial revolution, Well, are we on in the cusp, middle of, divergent problem, the fourth wave of globalism. On one hand, a scary thing or two that happened back around 2019, 2020, and a boat trying to do circle work in a narrow alleyway absolutely compounded certain sentiments towards bringing things back to a more local level. On the other hand, we have had an increase in the digitization of ideas, and ideas as well as designs flow. So we end up with two very different schools of thought: a renationalization and a reduction in global supply, JIT, just-in-time supply chains, and offshore manufacturing, cheap labor, cheaper parts. That's not going away. Like, let's be honest here. You can wave your banners around and go, bring manufacturing back. But if you're expecting $90 an hour and someone else will do it for $9, you're fucked, son. But on the other hand, the availability and democratization of the ideas and concepts through the sharing of plans data, the leaking of specifications, as well as the ability to knock down the gates of actually producing things, well, now we've got an idea that's globalized and production that's localized, but it's hyper-localized in that it doesn't even require local industry mostly, or does it? There's an overlap here. Quick supply chain overview. You used to have dig up stuff, manufacture material from stuff, move input material, make material into thing after moving it to where the cheapest place to do that was, which usually was not too far. Then move all of those things to somewhere where it was cheaper to build them relatively close to market space, take finished product from all of those parts and send to consumers via some sort of spoken hub delivery system. What we're probably going to see in a fourth wave globalism sense is a lot more ability for dig up stuff, make raw material into something which can be fed into a rapid fabricator. Have many, many rapid fabricators somewhere at last leg. Have all of the information about constructing, building, and fabricating it, reach it before the materials do. So when the materials turn up, 16 machines print out 16 different types of product, which are inputs to a final product, which can be picked up the next day. And consumer goods is probably going to go in a very similar manner, where I've always argued that the retail space with stock in the back is a really, really expensive waste of space in an ever-increasingly expensive commercial rental market. So instead, you'll have showrooms, you'll have places where you can have somebody show you on your iPad what your new kicks are going to look like. You can choose different parts of it, and you can have that particular specification with your uppers, your lowers, high top, low top, laces, whatever. Maybe you want some pumps put back in there for that real 90s swag. All of that specification will be done in store, where you can touch and feel different demonstration models, and you will wait for about a day and a half for people to rapidly fabricate parts of it and add it to a whole bunch of standard stocks, construct the thing, and dropship it to you. And in the case of some of it, it might even be dropshipped by drones, which knock out power cables or internet cables. Which one of those happened, Amazon? I'm going to do a little bit longer of a pop culture reference on this one, because William Gibson has a book called The Peripheral, which was made into a TV show with Chloe Moretz, whose camel toe photos are exceptional. However, so is the book. The TV show is pretty okie dokie, but it got cancelled, which is sad. They actually had this really interesting idea of a new manufacturing paradigm, where you had your Walmart of manufacturers making nubbins and licensed goods. You had your true black market manufacturers, which were doing sketchy shit like questionable peptides and drugs. And you had your kind of grey in-betweens, which are doing all your knockoff Nikes and Yeezys. Does anyone even wear Yeezys anymore? Because I guess they were comfortable despite everything. That kind of distributed manufacturing was rather interesting because almost everybody in town was employed by the Walmart-like licensed manufacturing company. Well, most everybody. However, the reality is that the entire town's economy was pinned up off of the Walter White wannabes around the corner, 3D printing supercrack. Bit of supercrack's probably necessary. Also, the idea that an entire manufacturing paradigm shift could reignite somewhere like a former manufacturing city that had lost all of its primary industry and bring it back from the dead, only to have that entire thing propped up by questionable black market industry. It's dystopian as fuck, but at the same time, you have to admit, it's pretty likely. You don't think that tax write-offs are paying for all those Ford Rangers, right? And to close out with regards to William Gibson for this video, it was him, I believe, who said, the future is already here, it's just not evenly distributed. That's the fucking truth. One of the most profitable companies in Britain needs to make money on making plastic toy soldiers. Fine. At the same time, they're attacking using legal methods not everybody who prints some sort of replacement toy soldier. They're actually not too stressed about the people who are printing them. What they are stressed about are the people who are selling the designs to print them yourself. This is extremely niche and it is extraordinarily outside of most people's realms, but they don't care that you bought their toy soldier or something that's looking kind of similar made by somebody else who went through the effort of putting up some infrastructure. They're terrified of everyone at home being able to just grab a file and make stuff. Going back to the car parts example, nobody really gave a shit when my mate didn't want to spend $40 on a tiny little grommet for his cruise control for his Falcon or his Commodore or whatever it was. If these days you were to use a rapid manufacturing device to create certain body panels, you would be sued if they caught on that you're making a buck off of selling them. What if you used a hammer? What if you were just really, really good with a hammer and a saw? Now we're seeing the difference. It is the democratization of manufacturing that is scaring the shit out of people who have power over our consumption. And God knows I consume. Alright, let's consider some more examples. How good would it be if a dude with a van, like the Pope-mobile the other day was turned into a rapid response van that could go out and help people? What if that, or the Lady Diana car, okay, maybe not that one, but what if a car was able to go out and print 3D printed prosthetics for kids that have lost their legs in landmine zones? Wonderful. That sounds really, 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 really good. The flip side there is, what if somebody can go out and make armaments using 3D printing? This is, well, it's generally considered not an ideal thing. The whole ghost gun problem, I don't want to get into it too much, but where we were really unhappy with the idea, and rightfully so, of a teenager being able to print themselves a bloody .22 caliber Muppet gun, we are pretty okie dokie with the Burmese uprising using a whole bunch of 3D printed submachine guns. I'm probably going to get in trouble for saying something in this space. I don't have a problem with guns, I just think they need to be treated with the respect that they're due. And that's not the same kid that printed off a whole bunch of Skitari also being able to shoot his mate in the heat of the moment after his Skitari were completely mogged by a whole bunch of goths. Fucking orcs. So what about the next level of bio-engineered printing? Because this is where we are now going. Where it used to cost tens of thousands of dollars to get a desktop biological printer of many sorts, they're now coming down to just a couple of grand or even a couple of $100 in some cases. Let's just park the fact that you can plug AI into this, and whether or not you believe AI is smart or not, it is very good at executing very limited, very specific instructions based on what it knows. It's a wonderful idea, and I believe it's a wonderful idea, that if you are having a novel outbreak of some sort of virus in bumfuck nowhere, that you should be able to have somebody cruise in a Hercules or a Galaxy or something with a full 3D printing setup for mRNA or something else, RNA, fucking whatever biological thing. I'm not a biologist. I'm barely biological. I've got so much plastic in me. I love the idea that they can rock up, they can sit there, and that they would be able to rapidly fabricate a large amount of very specifically customized vaccine to whatever outbreak it is. There, then, small runs, immediately created, like an mRNA targeted solution. Without proper safeguards, exactly the same technology could potentially be used to create less happy bringing things. As it is, the entirety of the genomic sequence of a hell of a lot of really nasty pathogens, including smallpox, which, it's gone for now. I mean, I'm sure it'll pop back up somewhere in fucking anti-vax land, especially with the emergence of this technology. But it's all out there. So, realistically speaking, once you couple together a offline, very, very capable learning model to something like RNA, DNA, viral shit, whatever, and you've got $2,000 devices, there's a negative there. That's a concern. Here's where the snake eats its own tail. We're in Ouroboros zone. Because I know the argument is, well, you just have safeguards built in. You have things that mean that they need to be always on and connect to the internet. Actually, I'll take a moment here and say Mustafa Suleyman, I think is how you pronounce his name. I don't know, I'm fucking too Australian for that. He is the current head of AI safety for Microsoft. He is a very accomplished dude. He has a book called The Coming Wave. I think it is on the must-read list. Do it. If you haven't, go Audible, listen to it. He knows his stuff, and I know the idea is that we would build all these wonderful biological fabrication devices with safeguards in them, such as always on AI scan, pre-printing algorithms that prevent anyone from just going and copy-pasting smallpox over, creating terrible things. However, I've also been around technology for a really long time. God, I'm old. And one thing I do know is that even without the intent of doing something terrible, what will happen is that someone will try to cheap on a few parts. They'll strip out this thing so that they can build it cheaper. They'll circumvent that thing. They'll realize that they can't get their hands on this piece of software, so they'll hack around it and they'll build their own thing. The minute, and it'll happen in minutes, that any of the designs for these devices get leaked, either through some exploit or some accidental leak or anything. We have these biological rapid fabricators, and they will be available. It's only a matter of time before patents expire, or alternatively, somebody copies and pastes into the wrong Discord chat, or somebody on a war game bloody forum decides they need to post a specification to get clout. It's only a matter of time before the design specifications and frankly, everything that would be required to make one of these yourself ends up out there. Now, I'm not saying that everybody will be able to. I'm saying the limited few people will be able to. However, out of those limited few people who will be able to, there'll be some people who either by intent or through trying to cut corners and make things cheaper, drop this module out, don't make it call home because information wants to be free. After all, they're building a leaked bloody RNA printer. They're going to get around any safeguard because ultimately it is a system that can do a thing. The digital side of it, signed this and bloody this, that, and the other one. How long did it take for the hardest DRM to get popped? It just always goes away. Information wants to be free. There should be a hacker inside of all of you who agrees with that. So eventually we're going to end up with somebody who can 3D print a RNA 3D printer or an mRNA 3D printer, or as it is, there's open source projects for 3D printing my hand back on, like Hawkeye out of fucking Age of Ultron. Does anyone remember that part of Age of Ultron where Hawkeye got his hand, like, 3D printed back on by a really inconsequential doctor who got kidnapped, and then she built Vision's body. The whole thing seemed pretty pointless because the only reason they were doing it was so that she could make a joke about being attracted to Thor, and her surname was Chow, which is Amadeus Chow, which is young Hulk's mum, but then they brought in Hulk's son, but they didn't bring Amadeus Chow in. The Young Avengers, like, what the fuck is going on, Marvel? Get your shit together. I'm fucking missing the good movies. Someone's gonna come up with a stripped down 3D printer that accidentally prints smallpox, or intentionally prints smallpox, or anthrax, or not. A weird cult with like one dude who wasn't even that good at chemistry managed to do the sarin gas bombings in Japan. You can already download a lot of the genomes to these terrible things. There's already expert systems, learning systems, LLM-like systems that can do work in order to redesign them. The only thing that's lacking at the moment is something to output them that is consumer grade. So what are we going to do? Regulate? Sure. Yeah, no worries. Click here to agree that you are a registered biochemist. Thank you, sketchy dark website. I'm glad you didn't ask me to upload a picture of my license. We can't even prove that 12-year-olds aren't adults to keep them off of anything. Well, why do we think we'll be able to screen the ability to download totally acceptable public domain knowledge that's out there right now? We're all fucked. But hey, we do have a history of defense very much outpacing offense. Fair chance that a whole bunch of people will be able to create the thing that stops the thing before the thing gets... It really is starting to feel very cyberpunk, isn't it? You know, this guy's out there creating this, and this guy's over here with a whole bunch of people creating that, and suddenly it's a whole bunch of people versus a corporation. Wonder if I can get modded to look like a shark. Nom 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 nom. That'd be cool. Look, I'd be remiss if I didn't take a little bit of a detour into space, because you know how much I hate it down here on Earth where all the people are. It's actually pretty cool. So while it was very, very, very expensive to ship a 3D printer up to the ISS, and they printed what would have been a like $3 or $5 spanner with it, the fact is that they could print that $3 or $5 spanner as many times as they needed. They printed a spanner. That's awesome. Where are all my 10 mils at? Only you're in orbit? I know that there's only like 8 people up there that could have pocketed you 10 mil. When you need a 10 mil, you never have a 10 mil. So they're also 3D printing rockets. Literally rockets. They did spend, what was it? Like 85% less time printing a 3D rocket, which failed. But in the rocket's defense, the 3D printed parts weren't what failed. You're not going to be able to get out there into habitats in non-Earth's world without rapid fabrication. We don't generally love rapid fabricators that fabricate themselves. That's a bit of a slippery slope. The old paperclip optimizer, where it just eats everything in the universe to make paperclips, and nobody's there to trade them with. One example that might be a bit different is the von Neumann probes. The von Neumann probes are probes that are designed to go out into space, fly out there, nom the shit out of things that it finds in space, build another von Neumann probe, and send it further into space. Realistically, the only hope humans have of leaving a presence further than Voyager at the moment. But as soon as we can get our shit up into space, on asteroids, on the moon, etc., we need to be doing things that consume materials and fabricate themselves. There's not even third industrial revolution requirements. That one's pure fourth generation fast fabrication and autonomous systems. The reality is we're at least 20 years away from self-replicating devices that actually build themselves. I'm not going to be able to sit there and go, hey, 3D printer, 3D print me another 3D printer, and then go eat that guy over there and 3D print me out some tasty, tasty protein. That, 3D print me another 3D printer, and then go eat that guy over there and 3D print me out some tasty, tasty protein. That, 3D print me another 3D printer, and then go eat that guy over there and 3D print me out some tasty, tasty protein. That, 3D print me another 3D printer, and then go eat that guy over there and 3D print me out some tasty, tasty protein. That, 3D print me another 3D printer, and then go eat that guy over there and 3D print me out some tasty, tasty protein. That, 3D print me another 3D printer, and then go eat that guy over there and 3D print me out some tasty, tasty protein. That, 3D print me another 3D printer, and then go eat that guy over there and 3D print me out some tasty, tasty protein. That, 3D print me another 3D printer, and then go eat that guy over there and 3D print me out some tasty, tasty protein. That, 3D print me another 3D printer, and then go eat that guy over there and 3D print me out some tas weirdly enough is a risk that we'll have to overcome though, which makes me wonder whether or not I should want to eat that guy's ass. Let's segue over to 3D printing houses. You can 3D print a house. You still need somebody to go through and do all of the plumbing and wiring while it's 3D printing. You can remove certain parts of the process and instead have something which is a giant car wash that shits out concrete or cement. Fuck cement. You can still have that doing a lot of the wall fabrication and so forth. If you're thinking that the answer to the housing crisis is 3D printing houses, I've got to ask you a question. If we're having trouble finding enough people who can literally go block, goo, and instead replace them with a small number of people who can operate a car wash that shits cement out, I do wonder whether or not you fully understand what a skills pipeline is. AI is tied into this really heavily. We're not dealing with the idea that someone can send you the blueprints anymore. What we're saying is, here's 100 blueprints of something that's been done. Now make me one of those. We're removing elements. And even if we make it better, honestly, haven't you seen the hallucinations you can get out of these things? Hi, I'm a body hacker. I want to have a particular type of whatever, peptide that makes me a better person. Bigger person. Like, honestly, you can't blame the swole boys for thinking the bigger is better. The LLM fucks it up. And instead, it gives them cancer. Or it has a really negative effect on their moves, like mine. You don't know. And that's before you even take into account the 4chan effect, where once upon a time they said, here, mix bleach and ammonia and blow really hard into it in order to make crystals. There are going to be the 4chan effects where people put up designs for things that you can 3D print that are going to be fucking catastrophic just for the keks, laughs. I don't know. All I know is I'm not baking cookies again because they only made fucking fire. Normally I'm the first guy who'll sit there and say, look, information wants to be free. I, at heart, believe that people should be able to do whatever the hell they want to, as long as it doesn't hurt other people, but the potential for it to hurt other people is there. Like, we can't ignore that. I think better things will happen. I think we'll always be able to come up with a better patch than the bug. That's the reality of it. Every time somebody does something terrible, there'll be somebody else out there who releases a fix. Things do need to be considered, but we are in a new world. It's here and it's now, and most of us haven't even realized it. It's great. Probably looking at some of the future of what readily available, home available, rapid fabrication offers makes me kind of feel like those who are sitting there and yelling it should all be available to everybody to do what they want with, that's a really hard ask as it stands. It's not all doom and gloom. How good would it be to go, you know what, today I feel like trying Orca and having your home 3D protein printer print you off some orca. I mean, it's going to taste like absolute shit. I'm pretty sure that penguins are not the best feed, but this is the best part. Then you can plug it into some sort of advanced AI and go, what I want is grain-fed orca. Because vegetarian killer whales are probably something we'll fucking print as well. For as long as humans can keep creating, keep collaborating, and keep sharing, I have no doubt we're going to literally build unicorns with all of this. And I, for one, am looking forward to tasting unicorns. And that's the trap that's been sprung that you've been watching this whole time. Really, what I'm saying is that the future is fraught. And maybe we just need to reel in that whole you've never succeeded if you hadn't failed attitude. I'm very much a big fan of saying, hey, if your first 5 drop shipping companies all failed, try 5 or 6 more. Maybe the 17th will succeed. However, there are certain things that really shouldn't be, hey, might as well just throw it at the wall and see what sticks and hope that it all works out. To put it simply, we spent 5,000 years stabbing and punching things until things fell off of them in order to make them. That was fine. We now started getting to the point where we can build things in an additive way, and those things aren't just large-scale physical things. they are, but they're also smaller. We can literally 3D print human brains. We're at the point in time where you can shit out a house using a giant spider, picture up here, print living 3D tissues, but not a new liver. Fucking hurry up with that one. Basically everything else in between is this far away. The question is, have we become better craftsmen through this process? Fuck no. Absolutely not. Not as individuals. Have we become better team players? Has community coalesced upon society? And is there a pathway for that in the future? Yes, I believe there is. Oh, I'm going to have to talk to people again. We will be able to do things faster. We will be able to do things more dangerously. And the bottom line is these tools exist and you can't stuff a cat back into a bag, but maybe a unicorn's ass instead of a pig into a blanket. The revolution is here. It's already fabricated. How long until your kids are? I'm Thaddeus Whacknamara, and I'm whacking on Unicorn ass?